We'll see some more question from IES exam of previous year question from strength of material. Okay, this will be for mechanical engineering and for civil engineering students. Okay, so we are going to see the questions of bending moment and shear force diagram. This is about myself. Okay, so this is IES 1999 question. Okay, आप लोग कुछ लोग ये सोच सकते हैं कि यार IES में कहाँ से आता है, तो 2010 से पहले प्रीलिम्स में भी ऑप्शनल चूज करना होता था। तो वहाँ पे अगर आप मैकेनिकल इंजीनियरिंग चूज करते थे तो वहाँ पे मैकेनिकल के क्वेश्चंस आते थे। ठीक है, 2010 के बाद से पैटर्न चेंज हो गया, तो वहाँ पे जो ऑप्शनल चूज करते थे वो खत्म हो गया प्रीलिम्स में। तो उसके बाद से यू विल नॉट फाइंड क्वेश्चन आफ्टर 2010। ओके, ये जितने भी क्वेश्चन IAS वाले होंगे वो होंगे 2010 के पहले के। ओके, सो डोंट वरी फॉर दैट। एनीवे, दिस क्वेश्चन ऑलरेडी केम फ्रॉम मैकेनिकल इंजीनियरिंग, वी शुड नो फॉर दिस क्वेश्चन। ओके, so if you are targeting in engineering services or GATE or any exams which has mechanical engineering as a syllabus, so you can use these questions because these questions are very nice question and sometimes very complicated, so that's why we should know that. Anyway, so this loading condition is given. They are asking what is BMD for this loading condition. So okay, so for this, see, here is also one load, here is also one load, and this is it is uniformly distributed. It is not uniformly distributed load, varying load but not uniformly distributed. Okay, so in this case D will be the option. Okay, we will do SFD and BMD for this kind of loading as well once we do the complete lecture series of strength of material. Okay, because if I'm going to solving these questions now, it will take a lot of time, so we'll deal it separate. As of now, you remember the diagrams. Okay, so if you remember diagram for 50, 60 or different type of loading, so in the exam, even if I finding some new problem, with those knowledge you can deal that problem as well, even if you don't know how to write the equations for shear force or bending moment. Okay, so that's why we should know these questions. But anyway, we will solve not only this kind of very complicated kind of loading as well. This is assertion reason problem. A simply supported beam carrying concentrated load at mid span. Both the shear force and bending moment diagram are triangular in nature without the change in sign. Okay, when the shear force at any section of beam is either 0 or changes sign, the bending moment at that section is maximum. Okay, see, first is wrong. Okay, a simply supported beam carrying concentrated load at mid span, both the shear force and bending moment diagram or triangle. No, this is absolutely wrong. Okay, but this is correct. When the shear force at any section of the beam is either 0 or changes sign, the bending moment at that section is maximum. Yes. Okay, this is correct. So the answer is D. Okay, so in first is not triangular, is rectangular. Okay, for the first case they are saying triangular. No, it is actually rectangular. Next, for shear force to be uniform throughout this span of simply supported beam, it should carry which one of the following loadings? Okay, a shear force to uniform throughout the span of simply supported beam, it should carry which type of loading? Which one of the following loading? Okay, a concentrated load at mid span, you deal over the entire span, or couple anywhere within its span, two concentrated load equal in magnitude and placed at equal distance from each support. So this will be actually you can see here this is the loading condition what they have given. This is the loading condition. So for this, shear force is this. Okay, so this will be a concentrated load equal in magnitude and place at equal distance for each support. So the answer is D. It is pure bending case. The next question. So obviously this is the loading condition is given. They are asking SFD, shear force diagram. Okay, so these are the four options that we have to choose. What will be the shear force diagram? Here the answer will be A. Okay, so for this section it will be a rectangle. For this section it will be a rectangle. Okay, and there is no loading, so there will be nothing. So the answer is A. Next question, we have to match this. Okay, shear force, slope of shear force diagram, maximum shear force, maximum deflection, magnitude of maximum deflection. Okay, there is a simply supported beam of length FL subjected to downward load of uniform intensity W. Okay, so this is the condition, and so we have to tell that what is the slope of shear force, maximum shear force, maximum deflection, the magnitude of maximum bending moment. Okay, so this slope of shear force. The slope of shear force diagram will be this W. Maximum shear force is nothing but is WL by 2. Maximum deflection is, you know that this is the formula for simply supported beam for the deflection 5 WL to the power 84 EI. Okay, and जो बचा वही हमारा लास्ट वाला हो जाएगा. The magnitude of maximum bending moment is 3. So the answer is D. Even if you know this, you can eliminate option A and option B. Okay, and if you know one more, you can answer this match list. Next question. Simply supported beam of length L is subjected to a symmetrical uniformly varying load with zero intensity at its end and intensity W or load per unit length at the midspine. What will be the maximum bending moment? Okay, so in this case, what will be the maximum? This is nothing but WL to the power WL is square by 12. Okay, it's a standard formula. You have to remember this. That is WL is square by 12. Next question. A simply supported beam of span L is subjected to a uniformly varying load having zero intensity at the left support and W per Newton per meter at the right support. Okay. The reaction at the right support is. Okay, so in this loading condition, they are asking what is the reaction at the right support. Okay, so this will be W. Very simple question. You just draw this loading. Okay, just equate the load from the reaction. Like let's say it is based on it is simply supported, so there will be two reactions R1 R2. Take okay, just write one equation by equating load and then take a moment at one point, okay, and simplify. Okay, then you will get the supports. So the one of the support will be WL by 3. Okay, so the answer is D. Next question. Consider the following statement for a simply supported beam subjected to couple at its midpoint. Okay, simply supported, so there is a couple at the midpoint. So the correct statement, the bending moment is 0 at the end at the ends and maximum at the center. Bending moment is constant over the entire length of the beam. The shear force is constant over the entire length of the beam. Shear force is 0 over the entire length of the beam. Okay. So here actually the bending moment at is 0 at the end and maximum at the center. This is correct. Okay, and bending moment is constant over the entire length of the beam. No, this is wrong. Shear force is constant over the entire length of the beam. This is also correct. Shear force is 0 over the entire length of the beam. No, this is also wrong. So the answer is C.